Now that we know how to draw, we know how to draw a graph from an equation, we know how to identify an equation from a graph. Now what we need to do is have a look at parallel lines. Now parallel lines are ones that never touch. So this parallel line is going to look something to the effect of this. That's hardly an accurate way of being able to measure this or to get an accurate equation for it. So what we'll do instead is we'll use algebra to get ourselves one. What I need to know is the equation of the original line. We know that that will follow the rule y equals mx plus c, and like in the previous video, I'll go hunting for the c value first. It's where it crosses the y-axis, and that happens at -2. So far I've got y equals something x minus 2. And then I'm going to find the gradient. So that is a rise of 1, 2 over a run of 1. So it is a rise of 2 over a run in the negative direction of 1. So its equation is y equals -2x minus 2. All right, now, when we go to look for the new one, there are two ways of going about this. We will take the second equation, and the first thing that we know about the new line is that it also has the same gradient. So we know straight away that this one is going to be y equals -2x plus c, okay? We don't know what the c is, but we definitely know that the gradient is -2, because if they're parallel, they'll never touch, so they've got the same gradient or same steepness of their line. If you are really lucky, you'll be able to count for it. So that looks like this. If we rise 2, run 1, rise 2, run 1, then we do actually in fact have the point that it travels through, and we can use a ruler and we can put that in. Now, if that's the case, then you'll be able to go, great, y equals -2x. It travels through here at +2, so it'll be +2. But you won't always be that lucky. This is a fundamental style question. These are the ones you saw last year in Year 9. If you can't count for it, if you miss that, sorry about that. So if you can't see where it lands on the y-axis, you're going to need to use a different strategy to find that. So what I'll do is I'll just rub this out, and we'll assume we have to use the new strategy instead, okay? So what you do instead is you work out what the coordinates of the given point are. So that happens where x is 2, y is -2. You only need one point on that line, anywhere on that line, one that you're confident in, or one that's given to you, and you can work out what the new line is. So let's assume that we're back at square one. The thing that we know about our new line is that its gradient is -2, but what we don't know is the c value, or the y-intercept. Now, at the moment, we've got three unknowns, a y, an x, and a c, and that won't do. But what we can do is we can take that one coordinate that we know and we can substitute in the values for y and x. So that means that y becomes -2. Then I've got -2 times x, which is 2 in our coordinate there, plus c. And now we've only got one unknown that we can solve for. So let's do that. We'll say -2 equals -4 plus c, and then by balance method, we will add 4 to both sides, and we'll find that c is 2. And now that you've found that, go back to what you were building for your new line and finish it. My new equation is y equals -2x, and your new c value of +2. And you've found the parallel line. Let's do the next one and make sure we've got that right. Okay. This time, let's find the original equation of the line again. So start off with the original. Okay, we know that it will follow the rule y equals mx plus c. Let's have a look for the c value first. It crosses at positive 2. So far we've built that y equals mx plus 2. Now I'll count for the gradient. I just need 2 points I'm confident in. A rise of 1, 2 over a run of 1, 2, 3. So I've got y equals 2/3 of x plus 2. It's a positive gradient and the line's moving positively, so I know I've got that right. Let's go for a new line. New line. Again, if you can count for it, okay. So rise of 2, so take the new point, rise of 2, run of 1, 2, 3. So we'd actually be able to cheat here. We could go straight in with the new line, got the same gradient, and then it passes through now at 5, and that would be done. But let's assume that we can't do that, and we've got to do it the long way. What we'd be stuck with is C, and you go, oh dear, now I don't know what YC or X is. Go and find the coordinates of this point. So this point happens at -3, 3. And what we'll have to do is we'll have to substitute those in as our y and x values to solve for C. So y becomes 3, x becomes -3. When you're multiplying fractions, remember, just make that integer a fraction so that it's a bit easier. Top times top, bottom times bottom. So I've really got 3 equals -2 plus C. Add 2 to both sides, we're just balance methoding here. C is 5. Go back to your original equation which you were building, so here, and now y equals 2/3 of x plus our new C value of 5, which I got from here. And that one's finished.